let's check out the solution challenge.
Let's do this.
Okay, I'll present my screen.
Welcome to the Google Developer Student Club's 2021 Solution Challenge. The mission of this challenge is to use Google technology to solve for one of the United Nations' 17 Sustainable Development Goals, aiming to end poverty, ensure prosperity, and protect the planet. Win cool prizes, mentorship from Google, and swag. Get help along the way from Google at training events, code labs, and hackathons. Submit your solution by March 31st, 2021. Register today. We can't wait to see what you build.
Let's get started.
Developer student clubs are university-based communities where students learn about Google technology and use their skills to solve local problems. Welcome to the Developer Student Club's 2020 Solution Challenge Demo Day.
I'm really excited about this summit because I get to learn a lot of new stuff, and DSC really helps me to identify and make my skills grow.
DSCs are university-based student groups that come together and learn Google technology from each other.
In DSC, I could not only learn about technical skills related about technology, but also here I could learn about soft skills like leadership, communication, and also mentoring.
I've been developing NLP-based web applications at school, and with the Google technologies I learned at the summit, I'm looking forward to taking my project to the next level.
We expanded developer student clubs this year to more universities and more countries across Southeast Asia. It is this summit where their journey begins. Over the next 2 days, DSC leads learn vital technical, problem-solving and leadership skills from Googlers and industry experts before they go back to their universities to train more students, build projects and contribute back to the community.
The most memorable part of this summit is when we met other DC leads from different countries, learning their culture and sharing the same goal, and that is helping our fellow students with the use of technology.
The sessions that was most useful for me was how to build community, how to focus and respect the audience.
It's crucial that students are able to see the big picture and prepare themselves for their professional career. And that's what DSC does. It gives them a path for the future.
The DSC journey helped me build my passion in one area of technology and grow my career.
We want you to start connecting with, understand your community, understand your university, see what's going on in your city, talk to businesses, talk to NGOs, talk to your university, identify problem statements, and then work as a group to solve those problems and actually build solutions.
I'd like to make sure that no one in my community is left behind.
We're so excited to work with you all DSC leads from across the region, to see your career grow and support you solve local problems and create impact in your communities.
Hi everyone, my name is Vincent Regalado and I am the CEO and founder of Senti AI, and I'm also one of the Google developer expert for machine learning. So for today, we will be discussing a quick and brief introduction about machine learning. Then we'll also tackle about TensorFlow and what can you do using TensorFlow and what amazing machine learning application that you can build on top of this platform. So before we head straight, let's just try to revisit first our knowledge about machine learning and artificial intelligence. So just to recap AI, we know that artificial intelligence are the field of study in which we try to make machines solve problems that are commonly associated with human intelligence. So in the early 1950s, a lot of developments have been created, had been started to think about of ways on how we can teach machines how to comprehend, how to actually sense, and how to also recognize maybe text or also images. And another one of the things that went along the way into its advancement was the use of machine learning, in which instead of us trying to create rules for the machine to be able to learn, we are able to provide and collect data and provide these examples so that the machine is able to infer and recognize and understand what this example means and try to create their own rules. And in the early 2000s is where deep learning became relevant because of the explosive growth of computing power and more data being generated. So it's a machine learning algorithm that uses what we call as deep neural network. So just to by looking into a quick recap on how machine learning works. If we're going to create, for example, a task looking forward into an activity detection, it's fairly easy, right? If we're just going to assess the speed of a person walking, we can certainly create an if-else statement for that, that if speed is less than 4, we can assume that the person is walking. If the speed is greater than 4, it could probably be running. And if its speed is more than 12, it could be actually be biking. But if we're going to introduce a different type of activity, our machines or the rules are not trained to detect such, right? Therefore, we need to also create new rules for it. So this is one of the challenge in the early days of artificial intelligence, because you need to actually construct all of those rules by yourself. You need to construct all of those rules manually. And sometimes if you weren't able to experience or you're experience that specific type of activity in this case, you're not able to actually create new rules regarding it. So in the traditional programming, the early days of artificial intelligence, we are the one actually, or the humans are the one actually creating the rules and providing the data. And this is where traditional programming comes into play, right? So if we're going to assess, for example, if a person has COVID-19, which is relevant now, right? So if the fever is greater than 38, so probably there's a if the temperature is greater than 38, is a high fever. And so there's a strict rules that you need to follow, and you have an immediate answer for that, and then you code. So these are the expert systems come into play in the early 1950s, and because of the development of machine learning, so it's hard, again, as mentioned, one of the challenges in the traditional programming is the generation of rules. It is where machine learning comes into play, in which you provide examples, you provide the data, you provide the answers, and then the machine learning is the one who's going to generate those rules for you. Meaning, the more examples that you provide, the more idea or the more that the machine learning is able to actually extract those rules. So And so instead of just providing, for example, an if-else statement or a rule-based statement, you provide probably a sensor data and be able to label all of those data so that you are able to now determine what type of activities are those, right? So as mentioned, you have answers and data, and you do have the machine learning there, and then the machine learning is trying to able to generate all of those rules by themselves, right? And using those tools is where you are now able to actually capture new data, and this data will be using the model that you built, the rules that was generated previously, to make predictions. So you have two types of phases here. The first phase is a training phase in which you collate all of your data and let the machine learning algorithms do the rule extraction. And once you were able to generate those rules are compacted and placed into what we call as a model. And then you use now the model to actually train or infer or predict new data coming in. So this is what we call as the inference phase. So you have the training phase. This is where you train your machine learning model to learn more about the data. And then you have your inference phase. This is where you predict what's the model like, what's the classification of the specific data based on the model that you've built. So there's a lot of applications these days that have been using artificial intelligence and machine learning. You have your Gmail that does spam classification. You also have using Facebook, right? That when you upload images, it automatically classifies your friends' faces. And then there's a lot of work on artificial intelligence and machine learning these days. And then one of the unique flavor of it is you can contextualize it to the needs of a specific domain or industry. So it's not only limited to computer science, and it can actually be applied in a diverse set of domains that you have working together with experts. So one of the use cases that I'm going to show you is like an application called Air Cognizer, in which they use images to actually detect the quality, or they use the mobile phone sensors, which includes the camera, to detect the quality of air in India. They also have used, especially in the health space, they use the retina scans to be able to detect blood pressure, and to also identify if you have diabetic retinopathy. If we're going to look into, again, going to the health, in which there's a lot of data there, right? So they have been doing works on breast cancer detection, and in the context of the environment. So they have built a tool that is able to listen if there are any illegal loggers around the area, and tries to notify the rangers to take into action and identify the specific location so that they're able to monitor the vast forest, especially in Brazil. So Twitter itself has been using TensorFlow, and they have used different types of model to be able to extract relevant tweets that they could actually recommend to you based on your interaction on previous tweets. And together with GE, TensorFlow team have worked together to actually improve and create brain MRI systems to be able to understand and automatically define diseases on the brain itself. So there's a lot of applications in which artificial intelligence has made impact. One of the works that I have made during my bachelor's degree was to create a simple chat assistant that was way back in 2009, in which machine learning is like less known during that time, right? That we were able to create a simple machine that is able to teach the Filipino language, and that's where my love and interest to natural language processing in the context of Filipino language have grown. And there's a lot of applications now in which AI can actually be used, and I hope the listeners here today is able to also be inspired to use these technologies to make an impact. TensorFlow has been used in different communities, not only here in the Philippines. The power and impact of TensorFlow would not be possible without the community behind us continues to push, continues to educate a lot of users. And if you're if you haven't heard yet of TensorFlow, it's one of the platforms that enable you to build machine learning models for research and even for applications that would actually scale to support millions of users. So the growth of TensorFlow has been amazing since it was launched in 2015. It has been downloaded over 41 million times and has over 1,800 contributors worldwide. That's how vast the community of TensorFlow. And this growth has been amazing because it has also been used by researchers. They use TensorFlow for state-of-the-art research, and you can see in the paper publications on the past few years that they have been using TensorFlow now to build their models. What's unique in TensorFlow is that you can deploy anywhere. So once you build the model in TensorFlow, you can use it on servers, deploying it as an API. You can use it on edge devices, maybe on your mobile or on your IoT devices, and also on your website. So once you build your model, you can actually support different applications that you build in different modes, maybe on web, mobile, or IoT devices. So let's start with the overall architecture of TensorFlow. Probably if you're not familiar with this yet, there has been a lot of components previously in the first creation of TensorFlow. So let's look at it into like two phases. You have the training phases, in which you have a way for you to read and pre-process data, a way for you to actually clean your data, a way for you to make sure that this data is able to be processed immediately by the TensorFlow framework. And then you have your TensorFlow Hub. The TensorFlow Hub is one of the websites that you can use to download existing models. So instead of you building your own models, you can actually go and visit TensorFlow Hub. There's a lot of like pre-built models already that you can use, which allows you to speed up development of your machine learning projects. So in the training part, you also have your TF Keras, your pre-made estimators, and you have the distribution strategy. So the distribution strategy is a way for you to utilize different computing servers, maybe if you're using CPU, GPU, or TPUs to make your machine learning model training very, very fast. And the main output of the training is your seed model, going back to the main context of machine learning, right? That the main output is a compilation of rules in which we call a model. And in the context of TensorFlow, it's called state model. And this same model, you can now use it for deployment. If you're going to deploy it on the cloud, you can use TensorFlow Serving. You can use it if you're going to deploy it on Android, iOS, Raspberry Pi. You can use TensorFlow Lite for that. If you're going to deploy it on server, you can use TensorFlow JS. And there's a lot of like other language bindings that you can incorporate TensorFlow models. It's a very, very unique yet scalable machine learning framework, which allows you to build and deploy anywhere. So let's look into the training workflow, which is common into the TensorFlow framework. So you have your data ingestion and then transformation. This is where you're going to use TF data. We're going to discuss TF data later. And then once you build your model building, now you can use the Keras, and then you have your pre-made estimators for your model building. So it's a way for you to now construct your deep learning models and other models that you will be creating using TensorFlow. And then once you have built it, you can now do your training. You can use eager execution, autograph, distribution strategies, and TensorBoard. We'll be discussing some of these key components later. And then you're going to save it. You have your saved model. As mentioned, this is our training workflow, right? So we're just going to use all of these libraries and powerful API components in order for us to train a machine learning model in TensorFlow. So while training models, so whether packaged with Keras or more complex ones, it is often valuable to understand the progress and even analyze the model in detail. So instead of you trying to test it out and then trying to see if your model is actually doing great, TensorFlow is able to build a visualization tool called TensorBoard, in which it helps us to understand how does our model performs. And it now comes with full integration with Colab and other Jupyter notebooks, allowing you to see the same visualization right from within your notebook. So another key aspect is you can also use TensorBoard to relatively profile the performance of your model, right? You don't want your model to actually be slow. You would want to have it like analyze into predictions quickly. So Keras callbacks even include the full profiling of your model so that you can better understand your model's performance and its device placement, and you can more readily find ways to minimize this bottleneck. So this visualization tools in TensorBoard allows you to actually improve and find already the problems on your code itself, so that you're able to improve your model moving forward. So, and there's a lot of documentations available for you to use. If you can just go visit TensorFlow website. So if you can just go to TensorFlow website, you can already look into the different APIs available out there, TensorFlow.js, TensorFlow Lite, and then you can see all of the TensorFlow documentations in order for you to learn more about the capabilities and what are the libraries that you can actually use to build your machine learning models. So one of the key things that is very interesting in the TensorFlow ecosystem was the library called TensorFlow datasets. So we know that finding data is hard, right? Because again, even if data is already available in some of the websites, you have your Kaggle for it, but analyzing all of this data and pre-processing this data and feeding it to TensorFlow or feeding it to the preferred framework in which you're going to build your model will be is kind of challenging, right? So this is where TensorFlow was able to make it very simple, and they provided you with a list of data sets immediately that you can actually play on. So you have audio data, you have images data. You can already also use the diabetic retinopathy data in here. You have the ImageNet data, MNES data, and then you have text data in here that you can play around with and even translate in video. So this is already your some of the data sets that you can immediately use on the TensorFlow framework so that you can immediately learn and build models smoothly. And if you have your data yourself that you would want to add on the TensorFlow datasets, you can just go visit tensorflow.org/dataset/add_dataset. And this would definitely help the community, especially if we're pushing for an open community who would want to share more data. So as mentioned, just to have a quick recap, right? So we're able to discuss this and we will be continuously going to discuss this. So you have your training, Again, you have your data ingestion and pre-processing going into your model building, and then up until you were able to build and save your model. And then let's now move into discussing the key components in your deployment. Okay, so one of the key components in the deployment part is TensorFlow Lite. So if you are a mobile application developer, this would be very interesting for you. So TF Lite is a TensorFlow's lightweight cross-platform solution for mobile, not only for mobile, but also for embedded devices. And why TensorFlow Lite? So it actually allows you to deploy your models in small devices. And we know that machine learning shouldn't be limited on your desktop, on your server, right? And one of the challenges in deploying it in mobile devices is you need to make sure that it can actually execute faster while not eating a lot of your battery, right? So, and what's unique also in devices, it actually has majority of your data, and it can also contain, and it's also like personalized to your needs. So on-device machine learning allows you to build new types of products, which is customized to the needs of your users. This is what's unique when you're going to use TensorFlow Lite, because you are going to create different use cases that is contained on sensors, is contained on mobile devices, right? So you can now enable creation of a much more intelligent machines, intelligent IoT sensors, and applications. So one of the challenges that they try to actually resolve in the creation of TF Lite was to be able to reduce the compute power, to be able to also handle the limited memory, right? Imagine running a complex or high computational heavy machine learning model on a mobile phone. That would be challenging, right? So they were able to try to resolve all of this, and along with the battery constraints. So the TensorFlow Lite makes these challenges much easier. They were able to simplify creation or building machine learning on device. So what can you do with it? There's a lot of use cases that you can do with TensorFlow Lite. So there's available tutorials and on the TensorFlow website that you can use. So you have, if you're working with text data, so you can do classification, you can also do prediction. If you're working with speech data, you can do recognition. You can also perform text-to-speech and speech-to-text. For images, right? So you can now empower, or you can put more capabilities now to your applications on mobile. You can do object detection, object location, you can do OCR. We know that a lot of applications now have been using those unique capabilities, right? And you can also do just gesture recognition, facial modeling, and along with other many use cases that you can build using TensorFlow Lite to make the experience on mobile and embedded devices much more intelligent. So who is using TensorFlow Lite right now? So TensorFlow Lite has been deployed in production, okay? And it's been used by these different applications. So Google Photos, if you're using it, they're using TensorFlow Lite. And Gboard is using TensorFlow Lite. Your Gmail is using TensorFlow Lite. So a lot of applications as part of the Google family, the Alphabet family, have been using TensorFlow Lite. So as mentioned, there's a lot of tutorials available that you can use and build immediately. So you can just go head straight to the website. There's an image classification tutorial there, object detection, pose estimation, segmentation, and smart reply. So you can play around with all of these applications. So another component in the deployment is TensorFlow Extended. This is much more complex than TensorFlow Lite, but again, for you to actually recognize and know how do you now move models into actual production, right? So this is where TFX comes into play. So often the time, people always think that it's only the machine learning code that they need to worry about when they deploy machine learning projects. In reality, there's a lot more. You need to do data collection. You need to do feature extraction. You need to verify if this data are good. You need to also monitor if the model is still performing very well. You need to also make sure that the model is able to scale and serve. So there's a lot of other things that you will be worrying when you move into deployment. And this is where the TensorFlow Extended is the solution to this problem, because it is able to make it easy for you to be able to automate and build an end-to-end platform to manage every stage of the machine learning lifecycle. So TFX is able to allows you to manage from ingesting and transforming your data to deploying your machine learning models at scale. So in orange, you can see there the libraries that have been open sourced so far. And you can also see different libraries that you can immediately use now to deploy your machine learning models. You have your example gen, statistic gen, schema gen, example validator, transform. And the trainer is the one who's going to train your model. And then you have your evaluator, model validator, and pusher is the one who's going to push it to actual production. So TensorFlow Extended is like a completely different topic that we can actually discuss. But this is a way for you to actually scale your model and make it available for a lot of users. So as mentioned, if we're just going to put it on all together, so you have different timelines or like different runtimes that you can use. So you have your training and evaluation data in here that you use, and then you use, commonly they use Kubeflow runtime, and then you use this entire frameworks now to actually run statistics, to be able to validate your data schema, transform your data, do the trainer, train your data to build the machine learning model, evaluate if that model is actually accurate compared to the previous model that is that it previously built, and then validate and then push. And then the metadata stored in here is the one storing the history of what's happening in each of these key libraries. And then you have your other key components besides this entire TensorFlow Extended. You have also TensorFlow Hub, okay, that you can use. You have TensorFlow Lite, and then you have your TensorFlow JS is your entire infrastructure for deployment of machine learning models. So TFX powers the most important Google products in the Alphabet family and the major products within Google, right? So you have your Chrome, Android, your Google Maps. It also is powering like DeepMind projects, your Waymo, Verily, so all of this. And some of their most important partners, you have your Airbnb, PayPal, and Twitter, who have been using TensorFlow and TensorFlow Extended to run their machine learning models. And imagine how huge the users of these applications are. So that's what's unique. And in the context of TensorFlow, is able to do that, handle scalability, and to be able to serve predictions and for the machine learning models that you're going to build. So as mentioned, so all of this important information regarding TensorFlow, you can always like go visit their website to know more. And then you have your if you would want to know more about TensorFlow JS, you can just click on this website and this link For the TensorFlow Lite, you can click it here. For production, you can know more about TensorFlow Extended. So all of this information are here. There's a lot of tutorials available also on the website. So it would be easy for you to jump head straight to learn more about TensorFlow and build your first TensorFlow project. If you would want to be certified on TensorFlow, there's a certification for TensorFlow. You can just go visit tensorflow.org/certificate, and you can check the website and how you can be certified. So you can take an exam for like 100 USD to be a TensorFlow developer certified. So another resources that you can actually go into is you have your deep learning.ai introduction to TensorFlow for AI ML and DL. You can just go and screenshot this link. And then you can also go head straight to Udacity and just an introduction to TensorFlow for deep learning. As a recap, so again, you have your two main phases in the TensorFlow ecosystem. So you have a training, which allows you to build your machine learning models. And once you build this model, you can deploy this model into different deployment options. You can actually deploy it to mobile or IoT or embedded devices, could be deployed on your browser, or could also be integrated in other language bindings and deployed on cloud or on-prem. So that's how powerful TensorFlow architecture is. So I think that's it for my talk. So before I also end, I would want to also plug an upcoming event. I think we still have time for you to create your own project. So together with AI Pilipinas. So AI Pilipinas is the biggest AI community here in the Philippines. If you're not part of the group yet, just go visit aipilipinas.org or search us on Facebook and join the Facebook group and contribute and engage with the community. So we have an event called TensorFlow Project Showcase. So for those who would want to create simple projects, or for those who have existing projects in TensorFlow, we do recommend that you share it with us. Even if it's a small project, submit it, don't be shy. And our main goal really here is to help you guys to jumpstart into creating this project and share to the world and share to everyone that using TensorFlow and building TensorFlow projects is an easy game, right? So what can you get in here? You will be receiving, if you win the contest, you're going to receive a support to take the TensorFlow developer certificate for free. And we will also be giving and raffling off prizes such as Google Home Mini and Chromecast. So you just need to submit application and you get a chance immediately to win all of this win all of these like prizes. So again, this is Ralph. Thank you so much, and I hope you learned a lot. And again, as mentioned, if you want to learn more about TensorFlow, just head straight to the website tensorflow.org. Thank you so much, everyone.